to be looking at ratios and proportions today. So, by definition, a ratio is a comparison of two quantities. For example, Andrew is making orange punch for a party. He uses 2 cups of soda water for every 3 cups of oranges. So every 3 cups of oranges he puts 2 cups of soda water. So the ratio of soda waters, so I'm going to list that first, to orange juice, we can write it like this, 2 to 3. Okay. Or we can write it as a fraction, 2 over 3. So 2 cups of soda water to 3 cups of orange juice. So equivalent ratios make the same comparison. So sometimes you don't want necessarily just 4 cups of orange juice. You want to make half the amount. So you got to be able to know how to use equivalent ratios. So equivalent ratios make the same comparison. So for example, when we have 2 to 4 and 1/2, these are equivalent ratios. Okay. You can even write it as a fraction. 2 over 4 is the same as 1/2. Okay. There's 2 ways to determine equivalent ratios. The first way is to multiply. So multiply each term in a ratio by the same number. In other words, 4 to 6, I can multiply 4 by 2, and I'll get 8. And then if I multiply 6 by 2 as well, I'll get 12. So that's an equivalent ratio. It doesn't have to be the number 2. I could have chosen something else. I could have done multiplied by 3 or multiplied by 4, etc. So in this case, both terms were multiplied by 2. 4 and 6 and 8 and 12 are what we call equivalent ratios. So that's one way, you multiply. The other way is to divide. So you're making the ratio smaller. So you divide each term by a common factor, just like you do with fractions. So 4 I can divide by 2, and 6 I can divide by 2. So that's the number I'm going to choose. I'm going to divide by 2. It's not always 2, it just happens to work out like that. Oops. So 4 divided by 2 is 2, and 6 divided by 2 is. So I divided both numbers by 2. So both numbers were divided by 2. 4 and 6 and 2 and 3 are equivalent ratios. Okay, so let's practice some of these. Determine an equivalent ratio by multiplying. So I can multiply 3 and 4 by any value. So I can multiply it by 2. So that would be equivalent to 6 and 8. So I've multiplied that by 2. And I've multiplied this by 2. Or I could have chosen another number. Let's say I multiplied by 3. So times 3. 3 times 3 is 9. And 4 times 3 is 12. Okay, so there's various answers. Okay, equivalent ratio 5 and 6 times it by 2 times it by 2. Okay. Or let's say I want to multiply these by 2. Doesn't have to be 2, you can do 3, you can do 4. Okay. So you get equivalent ratios by multiplying both by the same number. So notice these are both 2, these are both 2, these are both 2, these are both 3. So they have to be the same for both. Okay. So another practice example says determine equivalent ratio in lowest term. In other words, it's telling me to divide. That's what lowest terms means. Okay. So 12 I can divide by 3, and 3 I can divide by 3, so I divide by 3. And I get 4, divide by 3, and I get 1. Here I can divide by 2, and I get 3. Here I can divide by 2, and I get 4. So here you're going to look to see what's the highest number I can divide by 120 and 100. The highest number that I can think of is 20. So if I divide this by 20, we'll know it's in lowest terms by checking our last ratio. So 120 divided by 20 is 6. I divide this by 20, I get 5. There's no other numbers that go into 6 and 5, so that means that I am in lowest terms. Okay. A proportion is a statement that two ratios are equal. For example, 5 and 4 and 25 and 20. Or x equals 12 to 2 and 5. We're going to learn how to solve these. So if you notice here, there's one unknown, x. I don't know what that x is, but because I have an equivalent ratio to it, I'm going to be able to solve for this. We're going to learn two methods of solving. So determining the unknown value. There are two ways to determine the unknown value in a proportion. One, which isn't always a preferred method because not all numbers will be able to do. You're going to look for a multiplication relationship. For example, if I look here, 4 to 12. What did I multiply 4 by to get 12? Well, I multiplied it by 3. So then I would have to multiply 5 by 3 to get x. So what do we multiply 4 by to get 12? 3. So multiply 5 by the same number, and 5 times 3 was 50. This method will not always work because sometimes you won't be able to see the number, or sometimes it's a decimal answer. It won't be as obvious. So the most preferred method is to rewrite the ratios in fraction form. And then we're going to solve for a method known as crisscross. Not crisscross, but cross multiplication. So we're going to write this first in fraction form. So 4 over 5 equals 12 over x. Then we're going to cross multiply. Cross multiply. Cross multiply is exactly what it sounds like, so it's a cross. So 4 times the x, that's 4x. And then 5 times the 12. So 4x equals 60. Divide both sides by 4. and x equals 50. So this is what we call cross multiplying, and you'll be doing this a lot for solving. So let's look at example 3 and practice this. Determine the value of b. So first step is always to write as a fraction. So 5/8 equals 45/b. So cross multiply. 5 times b is 5b, and then 8 times 4, 55. That's 5b equals 360. Divide both sides by 5. So b is equal to 72. Let's do this again. Next one, b times 4. I'm going to do the one with the variable 4 first, so it's on this side. That's 4b. And then 3 times 16. So 4b equals, meter, 4b equals 48. Divide both sides by 4, and b is equal to 12. So b over 20, again, write it as a fraction first, equals 18/15. b times 15 is 15b equals 20 times 18. 15b equals 360. Divide both sides by 15. And b equals 24. Now we're going to look at some word problems. Eric earned $150 working 5 hours. How long would it take him to earn 600? So how long is the question? So we're looking for unknown time. Okay. So $150, I'm going to write here, that's my wage, or the money earned. I'm going to write that over 5. That's the number of hours worked. I'm writing these out so I can match them up when I actually write the next ratio. That's one ratio. How long? I don't know. Would it take him to earn 600? So 600 has to go at the top here because that's the money he's going to earn. Okay. How long? I don't know. So I'm going to represent that with a variable. I'm going to call that x. Okay. So I'm going to let x represent the number of hours. So cross multiply 150 times x. So now I want to know what x is. Equals 600 times 5. So 150x equals 3000. Then you divide out 150 so I can know what 1x is, not 150x is. and I get 20. So this symbol here, the three dots, we haven't seen before, that represents therefore in math. So we always write a concluding statement. So therefore Eric, my final statement here, needs to work 20 hours to earn $600. So it's important you highlight key things, you label things so you match them up. Here I labeled, I made sure this was money and I put the money on the other side on top, not the bottom. Hours worked went on the bottom, so the hours worked that were unknown went on the bottom. And therefore statements are important when you have word problems. So these are questions with words, the problems that I'm solving with using math. Example 6. If 24 students are in a classroom where the ratio of girls to boys is 3 to 5, how many students in the class are girls? How many are boys? So they give me the ratio of 3 to 5. That's girls. And that's boys. How many students in the class are girls? So they're telling me a total number of students in the class. They're not telling me how many boys there are or how many girls. So I need to find a ratio with girls to total number of students. So total comes from adding 3 and 5. 3 and 5 gives me 8, because that's a total number of students in that ratio. So I can take this ratio now and solve for how many students there are in the class that are girls. So 3 over 8, so girls, the total, I want to know how many in the class are girls, so that's my x. The total is 24. They give me that here. Now that I only have one x that I don't know, one variable, I can cross multiply. 8 times x is 8x, equals 3 times 24. 8x equals 72. Isolate x, so divide by 8, divide by 8, and x equals 9. So that's the number of girls. I can solve the number of boys doing a ratio as well. I can do 5 over 8, or I can simply know now to find that. If I know there's 9 girls, I can just do, to find the boys, I can do 24 minus 9, and that gives me 50. Okay, so therefore, there would be 9 girls and 15 boys in the class. One last question. It seems I skipped example 5. When a robin flies, it beats its wings about 23 times in 10 seconds. Spelling error here, should say seconds. How many times, so here's my question, will it beat its wing in 2 minutes? So let's write down what we know. We know it beats its wings 23 times in 10 seconds. So this is time in seconds. So you want to know is how many times, so that's my unknown. How many times it beats its wings. And then it gives me 2 minutes. This needs to be in seconds, so there's 60 seconds in a minute, so 2 times 60, it goes 120 seconds. All right, 120 here. Now I'm going to cross multiply. 10 times x is 10x equals 23 times 120. 10x equals 2,760. Divide both sides by 10. And x equals 276. So therefore, the robin beats his wings 276 times in 2 minutes, or you can write in 120 seconds. And that's equivalent ratios.